Hello, my dear students. Welcome to the class of 11th English Medium. The subject is Statistics, Chapter 6, Permutations, Combinations, and Binomial Expansion, brought to you by Vitan Sir. Previously, in this chapter, we have completed permutation and combinations. This time, I am going to start with the last concept of this chapter. Before that, I would like you guys to remember some of these expansions which you have studied in previous standards. Let's say a plus b whole square. Ring a bell. The answer here is a square plus 2ab plus b square. And if I change the sign to negative, it becomes a square minus 2ab plus b square. Then we also studied a plus b whole cube. So if you don't remember it, it's okay. It is going to be a cube plus 3a square b plus 3ab square plus b cube. And if again I change the sign, it becomes a cube minus 3a square b plus 3ab square minus b cube. Now you might be saying that these has been taught before so many years. So how we are going to remember it? The point here is not whether you can remember this or not. The point is whether you can calculate this or not. When you were children and when you were taught this four expansions, you were not actually taught how to calculate them. You were just given the results and told to mug up. In this chapter, we are going to find the method of finding these expansions so that you will be able to calculate a plus b whole raised to 4, a plus b whole raised to 5, a plus b whole raised to 6, and if you want, you will be able to calculate a plus b whole raised to 10. Of course, that is not part of your syllabus, but once I teach you the method, you can calculate the expansion for any number of power you want, not just 2, 3, 4, 5, or 6, any number of power you want. Okay, so that's what we are going to study in this particular topic of binomial binomial expansion. So we are going to learn how actually do we expand these binomial variables with their specific powers. You were given direct forms. Now I'm going to teach you how. Now, to know the expansion value, we first must determine its coefficient. That means if I want to know that what is the expansion of a plus b the whole square. So I know this expansion here, but do you know the meaning of coefficient? Coefficient means that the value which is multiplied with these values here. See here a square. So we can just say that it has been multiplied with 1. This is 2ab, that means ab has been multiplied with 2, and last one is b square, so we can again assume it is 1. So actually the coefficients of these three terms are 1, 2, 1. That means a square has been multiplied with 1, ab multiplied with 2, b square multiplied with 1. To clarify it further, let's write down a plus b whole cube. So now this is the expansion of a plus b whole cube. So I can just say that a cube has been multiplied with 1, 3a square b. So a square b has been multiplied with 3, ab square has been multiplied with 3, and b cube has been multiplied with 1. Now if you are wondering why I'm doing this, these coefficients are very important for the purpose of calculating the expansion values. If we know these values of coefficients, for example, if I know what will be the values of these coefficients for the expansion of the power 5, that is a plus b whole raised to 5, then 50% work is done. So first step is knowing what your expansion coefficient values will be for your expansion. And there is a method for this purpose given by a statistician named Pascal, and the method is called Pascal's triangle. Now this triangle can be depicted using a table, and there is no end to this triangle. You can calculate this triangle on your own. I will just let you know how. power n, that means we have raised to 1. Okay, a plus b raised to 1 is just a and b. Then a plus b raised to 2 is a square plus 2ab plus b square. So raised to 3, 4, 5, 6, 7 and so on. Then these are the coefficients for those powers. So a plus b whole raised to 1 is just a and b. So that would be 1, 1 and so on. I will let you know. And the total of these coefficients is also important because there is a specific formula. Each power has its specific method of calculating the total. Let's see. Let's just say, okay, the power 1, that is a plus b whole raised to 1, will get you a and b. So a and b both are multiplied with 1 and 1, and the total here is 2 raised to 1 is equal to 2. So because the power is 1, then 1 will be put in the base of 2. So 2 raised to 1, the answer is 2, that is 1 plus 1, 2. Okay, if the power is 2, now if the power is 2, how we are going to write it down? First of all, we are going to write down this one in a cross value here, so it will be just 1. Then we will make a total of both of these ones here, that will get you 2. Okay, and then this one will be again written in the cross value here, that will give you 1. So now this becomes 1 to 1. So when you make a square of a plus b, you get a square plus 2ab plus b square. And when you make a total of these three values, 1 plus 2 plus 1, you get 2 raised to 2, 4. That is 2 into power 2. This is power, right? So 2 into power 2 is 4, and that's your answer. So you can actually verify whether you have written your coefficients correctly or not. If you have a doubt, just make a total of these coefficients, and if you get this answer, then yes, you are correct. Let's see the third one. Now here the power is 3. So first of all, we are going to write 1 in the diagonal manner. Then I'm going to add 1 and 2 and write the answer in the center here. Again, I'm going to add 2 plus 1 and write the answer in the center here. And then I'm going to write this one diagonally here. I think you guys are getting this, right? 1, 3, 3, 1. A cube plus 3a square b plus 3ab square plus b cube. This is the expansion of the a plus b whole cube, and just make a total of these values. You get 2 into power 3, that is 8. 1 plus 3 plus 3 plus 1, 8. 2 into power 3, total is 8. Okay, now we are going into an unknown territory here. You don't know what are the answers. Till now you knew that okay, these are the answers we could verify, but we are going to follow with the same system and we will get the coefficients for 4, 5, 6 and 7. Okay, so starting with the diagonal 1, then 3 plus 1, 4, then 3 plus 3, 6, then 3 plus 1, 4, and then diagonal 1. And because it is 2 raised to 4, you can verify it by making a total of these values. You will get your answer 16. So when you make write down the coefficients for the level 4, the total of all the coefficients should be 16. Fifth power, diagonal 1, then 1 plus 4, 5, 4 plus 6, 10, 6 plus 4, 10, 4 plus 1, 5, diagonal 1, 1. So when you write down the expansion, you see these number of terms are increasing here. When you had just a plus b square, you had 3 terms. Then a plus b cube were 4 terms. So naturally a plus b raised to 4 will be 5 terms. A plus b raised to 5 will have 6 terms. Okay, the number of terms will keep on increasing as you raise your power, and this total of all these coefficients will be 2 raised to 5, that is 32. Next, raised to 6, diagonal 1, 1 plus 5, 6, 5 plus 10, 15, 20, 10 plus 5, 15, 5 plus 1, 6, and then again 1. So now these are the coefficient values for the power 6. And when you make a total of all these coefficients, you will get the answer 2 raised to 6, that is 64. And the last power for this particular table. You can do it as much as you want. You can go take it up to 8, 9, 10, 11, 12. You can find it on your own, right? You just need to make a total using the previous power. So right now for the power 7, diagonal 1, then 1 plus 6, 7, 6 plus 15, 21, 15 plus 20, 35, 35, 15 plus 6, 21, 6 plus 1, 7, and again diagonal 1. So these are the coefficient values for the a plus b raised to 7. These are not the expansion values, these are the coefficient of the expansion. Okay, and the total will be 2 raised to 7, 128. So right now we have completed the 50% of the work. That is, if I want to know a plus b raised to 5, the half of the work is getting my coefficient values. The second half is deciding what power of a and b will be applied to each term. And there is an easier system of doing that. Let me show you. But before I show you, don't forget to write down that Pascal's triangle in your notebooks. Okay, copy the whole triangle in your notebooks because you are going to need that triangle for solving any kind of binomial expansion sums. So if you have not, just go back, copy it down, and then move forward. Okay, we will take our same old example because we are familiar with it. Okay, so the square and the cube values we already know. Okay, that's the answer. So we will compare that how we got that answer. First of all, for the power 2, the coefficient values are 1, 2, 1. Agreed, the coefficient values are 1, 2, 1. Now how are we going to write the remaining values here? First I am going to start with a and the total power here is 2. Okay, so when I write down the a here, I'm going to write it with the power 2. Then I will again write down the a here but with one less value, that is 1, and then again I'm going to write down a here but with one less value again, that is 0. So because my maximum power was 2, a raised to 2, then a raised to 1, then a raised to 0. So in a decreasing order I am writing down here. Then my second value is b, and b I am going to write with increasing order starting from 0, 1, 2. Now if you are wondering that sir, in the first term b is not there, in the last term a is not there, but my dear students, b raised to 0 just means 1, so ultimately it is going to be removed. A raised to 0 means again 1, so ultimately it is going to be removed. But this is the system, this is the logic we are applying. Okay, so what we did, first we write down the coefficients, then we start with the first value in the decreasing powers with the maximum to 0, then the second term with increasing powers from 0 to maximum power. Okay, so now because there is a positive sign, I am going to put positive sign between all this. 1, it doesn't matter whether we write down or not, anything raised to 0 is 1, so again doesn't matter whether we write it down or not, so we will get a square. A raised to 1 and b raised to 1 just means a and b, so it is 2ab. 1 and a raised to 0 will be removed because it is again 1, so just b square will be there. So my final expansion here will be a square plus 2ab plus b square. So this is how you expand your values. Now if you are wondering, sir, it is just easy to mug it up. You can mug it up, but how many can you? Can you mug up the expansions up to power 10? Can you mug up expansions up to power 15? Which one is easier, calculating on the spot or mugging it up for years to come? If I tell you after 5 years to remember a plus b raised to 5, can you? And one more thing, my dear students, we are not just going to expand a plus b and x plus y. We will be using some practical sums in which mugging up is not gonna work. So what you need here is the logic and the system. So remember the system. Next, if I am taking a minus b raised to 2. Now, if you are wondering how do we convert these same values using the minus sign, you know that these values never change, whether it is a positive or negative, just the signs here change, and the logic of signs is alternating the signs. If I am finding it out using negative sign here, a minus b raised to square, then the first sign here will be positive, then this will become negative, then again there will be positive. So alternating them, plus minus plus minus plus minus, no matter what number of terms we have, we start with the plus and then minus plus minus plus and so on. So your expansion here, the terms will be same, the signs will change. The first sign is always positive, so this is always positive value, and then we have negative, then positive, then negative, the positive, the negative. You will know it in a moment. Let's take a plus b cube. Now the coefficients for the power 3 are 1, 3, 3, 1. Okay, so these are the coefficients. I'm going to start with the first term with the maximum power 3, a cube. Then in the decreasing order, a square, a raised to 1, a raised to 0. Getting my point here? Start with the maximum power for the first term, a cube, a square, a raised to 1, a raised to 0. Then we start with the second term, b, with power 0, and then in the increasing order 1, 2, 3. Now because there is a positive sign here, all the values will be positive. So plus plus plus. Now this 1 and b raised to 0 doesn't matter. A square and b, a and b square, 1 and a raised to 0 will be removed. So the final result will be a cube 3a square b 3ab square b cube. So you are using the same system here and you are getting the same answer which you studied in your previous standards, which you had to mug up, but not anymore. If I take a minus b cube, the first value will be positive, second will be negative, third will be positive, fourth will be negative. Alternate values, positive, negative, positive, negative, positive, negative, positive, negative, dot 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 dot. But let's take something which you don't know. We have done the squares and cubes in earlier standards also. Using this same logic or system or method, let's try a plus b whole raised to 4. Now the coefficients for the level 4, you have it in your notebooks, are 1, 4, 6, 4, 1. Then the first term is a with the power 4. So a raised to 4, 3, 2, 1, 0. Okay, a raised to 4, a raised to 3, a raised to 2, a raised to 1, a raised to 0. The second term is b. We will start it with the 0 power. Okay, b is 0, 1, 2, 3, 4. If you don't do this, you will never get your answer. First term starts with the maximum power, second term starts with the minimum power, and the first term goes into the decreasing descending order till 0. The second term goes into increasing order till the maximum power possible in the question. So now when we simplify this, 1 and b0 is removed, 4a cube b, 6 a square b square, 4ab cube, and this 1 and a raised to 0 is removed, b raised to 4. So when you expand, this is something new for you. You guys have never done this before. A plus b whole raised to 4. The expansion here is, congratulations, you have done it. A raised to 4 plus 4a cube b plus 6a square b square plus 4ab cube plus b raised to 4. And if you are confused, you can just Google it. Okay, try to Google it. If you want, you will get something similar. So if I take it as a minus b raised to 4, first value will be positive, negative, positive, negative, positive, and you get a raised to 4 minus 4a cube b plus 6a square b square minus 4ab cube plus b raised to 4. Okay guys, a little something self-study work. Find this. A plus b raised to 5. What will be the answer? You have to use the same system. Try starting with writing down the coefficients for the fifth power, 1, 5, 10, 10, 5, 1. Then start with the first term, a raised to 5, then a raised to 4, 3, 2, 1, 0. Then start with second term, b raised to 0, then b raised to 1, 2, 3, 4, 5. Because this is plus, write down plus between all the values, simplify them. And once you are done with that, Find a minus b raised to 5. The first term will be positive, then negative, positive, negative, positive, negative, positive. Get it done. I think you guys can do it here. Okay, all the best. And once you are done after writing down these answers, move towards the next slide. Now there is a small problem with using Pascal's triangle. Although Pascal's triangle is considered the easiest method for the binomial expansion, there is a small problem. Whenever you need the coefficients, you either have to draw the whole triangle. That means if you want the coefficients of the 7th level, you need the whole triangle, right? If you are in examination hall, you have to write down the whole triangle for the purpose of calculating a 2 marks question. Or you have to memorize coefficients for all powers, that is ranging from power 1 to power 7. You need to remember the values for each and every level, the coefficients for each and every power. Now that is not an easy task. If I tell you guys to remember squares from 0 to 20 or cubes from 0 to 20, it's that difficult. So what happens that doing either of this is a bit difficult, and if you are writing down the whole triangle, it's time consuming, which we don't have enough during examinations. So there is another method of calculating coefficients for each powers, and you are familiar with, you know that method. Okay, it is possible that without writing down the whole triangle or without memorizing the whole triangle, you can calculate coefficients directly for the power 6 or directly for the power 8, whatever you want. And we are going to use the concept of combination for that purpose. Yes, the second concept, combination, of this chapter which we studied, we are going to use the same concept here. How? Let's see. A plus b raised to 1. Now this is power 1. When there is a power 1, it only means a, b. So for power 1, the coefficients were 1, 1. Now here the power is 1, so the value of n is 1. So what I am going to do, I am going to write down 1c0 and 1c1, because if the combination value, the maximum values are 1, then I only have two options here. I can take 1c0 or I can take 1c1, because this value cannot be less than 0 and this value cannot be more than 1. If I have 1 here, I can't take 2 or 3 or 4 or 5, anything here. This value should not be exceeded by this value. This is NCR. So it can be NC0 or NCN and anything between that, but nothing more, nothing less. So if we take 1C0, it is 1. And if I take 1C1, it is again 1. Ring a bell? Does it look similar to our first level of Pascal's triangle? If you are still confused, let's try with a plus b square. Because this is 2, now I can take 2c. And when I start with 2c, I start with 2c0. Then I add a value, it will become 2c1. And because still I can go further, I will take it 2c2. So all the possible combinations using 2. 2c0, 2c1, 2c2, 2c0 is 1. Now 2c1 is 2 and 2c2 is again 1. Did it ring a bell? Yes or no? And if still not, let's take a plus b cube. So the power here is 3. So now I'm going to take it as 3c0, then 3c1, then 3c2, and then 3c3. So this is 3c0, that is 1. Then I have 3c1, that is 3. Then I have 3c2, that is again 3. You can calculate it using your calcs if you want. This is nothing new for you guys. We have already completed combination. And then 3c3 is again 1. Now there should be a lot of bells ringing in your heads, right? 1, 1, then 1 diagonally, 1 plus 1, 2, 1. 1 diagonally, 1 plus 2, 3, 2 plus 1, 3, and 1 diagonally. This is the third level of your binomial expansions Pascal's triangle. That means Without writing down the whole triangle, if I know my power, I can calculate using this combination concept these coefficients, and using these coefficients I can directly find the expansion of any given term. Yes or no? Okay. If I want to find coefficient for power 7. So that is 7C0, 7C1, 7C2, 7C3, 7C4, 7C5, 7C6, 7C7. Now 7C0 is 1, 7C1 is 7, 7C2 is 7 into 6 upon 2, 21. 7C3 is 7 into 6 into 5 upon 3 into 2 into 1, 35. Now 7C3 is equal to 7C4. This we have already discussed in the concept of combination. That means it is 35. Then 7C2 is equal to 7C5. 7C1 is equal to 7C6 and 7C7 is 1. Is it according to our 7th level of Pascal's triangle? Yes, it is. That means using this combinations we can calculate any level or any power of coefficients without remembering, memorizing or writing down the whole Pascal's triangle. Let's check one out. A plus b whole raised to 6. Okay, this is something which we have not done. A plus b whole raised to 6, that is the power of 6. So 6c values we are going to calculate, that is 6 is 0, 61, 62, 63, 64, 65, 66. And the first term is a. The maximum power is 6, so a raised to 6. Then 5, 4, 3, 2, 1, 0. Second term is b, so b raised to 0, b raised to 1, 2, 3, 4, 5, 6. And then because there is a positive value here, plus signs everywhere. Now 60 is 1, 61 is 6, 62 is 15, 63 is 20, 64 is 15, 65 is 6, 66 is 1. You can just check it out with the Pascal's triangle which you have written down in your notes if you want. This is the 6th power value for the Pascal's triangle which we calculated without using it. Next, a raised to 6, and because there is a b raised to 0 we are not going to write it down. Then a raised to 5 and a raised to 4, a raised to 3, a raised to 2, a raised to 1, and because there is a raised to 0 we are not going to write it down naturally. Then b raised to 0 we are not going to write, so just b raised to 1, b raised to 2, 3, 4, 5 and b raised to 6, and then positive signs everywhere. And when you do, the final answer will be a raised to 6, 6 a raised to 5b plus 15 a raised to 4b square plus 20 a cube b cube plus 15 a square b raised to 4 plus 6 ab raised to 5 plus b raised to 6. So when you expand a plus b raised to 6, you get this expansion right here created in front of your eyes out of scratch. So this is the method of creating binomial expansion. Symbolically, this can be written as, now this whole gibberish is going to be very many symbols, just mug it up. Okay, this is just a high level. This is official method of writing down expansion in symbols rather than values. X plus a whole raised to n will be nc0 x raised to n a raised to 0. See here, nc0, nc1, nc2 dot 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 ncn, x raised to maximum power, then less 1, less 2, and then 0 power, a raised to minimum power 0, then a raised to 1, a raised to 2, a raised to n. So symbolically when we write down the expansion, this is written like this. You need to remember it, of course. Expansion of x plus a raised to n is called binomial expansion, and NCR x raised to n minus r a raised to r is the r plus 1th term of binomial expansion, also known as the general term of x plus a raised to n. You will need to remember this concept in many times MCQs or 1 mark questions. This kind of things are asked, so don't forget them. Next tutorial when we study, we will start with some practical sums based on this concept of binomial expansion. I hope you liked my method of explaining this concept. You might have recalled how you struggled for remembering those squares and cubes, but now you will be creating the powers 6 and 7 in front of you using your own logics and without mugging up anything. Thank you very much for watching this video. Please give me a thumbs up if you are new. Do subscribe to my channel. Share this video with your friends if they are not going to school right now or getting proper educations or understanding of these concepts. In case of any feedback, put a comment below. Thank you very much, and I will see you next time. Welcome students to Vitan's Unacount Academy. That's better way to success for you. I am Vitan Vora and I teach accountancy, statistics and social science. You can contact me on my cell number 919426310184. Please give a sub to my channel and also check out my other video playlist which you can see on the screen. Thank you and I will see you in the next video.